And now I want to explain what the course project is about. So this is 40% of the entire mark, so it is very, very important. Basically, when I thought about this course project, my motivations were the following. So I wanted to think of something where each team has the same kind of flavor, but different data sets, so you cannot directly copy from other teams, but rather you have a research-like project that only lasts for one semester and that you can do together. It is big enough with versatile roles that you can perform, so that to keep you really busy for the entire semester. Something that is related to, that involves reading actual research papers and producing actual reports. Something where you can work together on part of it and you can work individually on other parts. Something interesting and related to real life, and I hope that it is going to satisfy all these properties. So basically, let me explain how it is going to be done. First, it begins with research. Means that you just browse the web or the library. There will be a lot of articles posted on NTU Learn that you can read, and you can do your own Google search. Basically, you need to read literature on modeling real-life problems with differential equations. And the main article that I have in mind is by Sergio Rinaldi. It is called Laura and Petrarch, an intriguing case of cyclical love dynamics. And it is very beautiful. So the author analyzed a 23-year relationship between Laura and Petrarch. So Petrarch is a great Italian poet who lived in medieval ages, in 13th century, I think, or maybe even 20th century. Anyway, it was a long time ago. So he loved this woman Laura for most of his life, and he wrote a lot of poems. And the author of this article analyzed emotions presented in those poems, and he analyzed kind of the feelings of Laura towards Petrarch and Petrarch towards Laura, and tried to model these emotions with a system of differential equations. Right? So that's what you can do too. Or you can read more papers to invent another topic. So the default topic is modeling a love story with a system of differential equations. Right? So the standard topic is where last year it was the same, and last year most teams just thought of a movie or a book and tried to invent a system of differential equations that captures the love story in the movie or in the book. You will have access to all the last year's reports. You can read them, so as a part of your research. So that's what you can do by default. If you don't want to do the default topic, then you need to invent your own, something original. And then, after you've invented the topic, so you need to set up a model. So you need to think of a system of differential equations with parameters that models the love story here or something else. And it should somehow be logical. So there must be certain, a logic that links the love story with differential equations. I think it is a very interesting thing to do, and these 3 steps should be done together as a team, right? So research, topic selection and modeling, this is all to be discussed among all the team members. But then there are certain parts of the project that can be done individually, or I don't know, in small subgroups. For example, data collection, meaning that if you want to do a love story, then you just watch a movie together, you identify key moments, and you somehow try to measure emotions of the individual, of the two individuals or three individuals at those moments, and you want to put them into an Excel spreadsheet. So this process can be, of course, done by just one person. Or, again, if you prefer, you can discuss it among all the team members. I think usually this is done in pairs. So if just two of you want to sit together and go through the movie and do this, that's doable. So after you've done the model and you've done the data collection, on week 8 there will be the first presentation. So in the first presentation you explain your topic selection, you do this data analysis, you present the model. So the first presentation, of course, it has to be prepared by someone. So one person may prepare the slides, but the thing is that presenters will be nominated by the tutor just one day before the presentation. This is needed to ensure that everyone participated in, say, the model construction. Because if one student just has no clue about the model construction and that student is forced to present, then sorry for the whole team. So as a team you need to ensure that everyone understands the model construction. Data analysis, since it does not have to be done by everyone together, so the person who is going to present the data analysis can be nominated by the team. But topic selection and the model, so one day before the presentation the tutor will tell you, okay, so team A, team, I don't know, team 1, so student A is going to do to present topic selection, and student D is going to explain the logic behind the model, and they have to do it. Alright, that's at week 8, so right after the midterm break. Then after that, more complicated stuff happens, so something harder. So specifically, one thing that you have to do is to feed the model into data, so which I hope you know how to do from Algorithms and Computing 3. The model here is going to be, again, recall, it is going to be a system of differential equations with parameters, right? But then you need to figure out how to, it's not just a simple function, it is a system of differential equations, so you need to figure out how to find the optimal combination of the parameters that feed the data as best as possible. And this is, I think it's the job of just one person, and the student responsible for this part can figure out how to do it on some, can start learning how to do it on some mock examples, on some fake data, but then once the actual data is ready and once the actual model is ready, so it will take very little time to run the computer program on real data. So another thing is simulation, is once you have finalized these two things are actually interconnected, so they're linked together, simulation and fitting the model into data. But the idea here is that once you feed the model into data, it means that now instead of a system of differential equations with parameters, you know the exact values of parameters, and you have a specific system of differential equations that is supposed to model the process that you are describing. So once you do this, you write a computer program that solves the system of differential equations numerically, and basically tries to predict what is going to happen in the long run. So if this is a love story, so what is going to happen? Is the love of the characters is going to die out, or is it going to develop cyclically like the Laura and Petrarch story, or is it going to converge to a certain point, or what's going to happen? So in order to do that, you need to run this computer simulation. And again, the student responsible for this part can learn how to do it in advance, but once the model is ready, you just run your computer program on that particular model and it's done. So the hardest part here is advanced mathematics. So it is optional, strictly speaking, if you that's the second optional thing. So the first optional thing is coming up with your own original topic. So what I promise is that if you do everything perfectly and you don't do the optional stuff here, then it is still sufficient to get an A. But of course, if you do this optional stuff, then your grade is going to be higher. So this optional thing is to apply some mathematical theories that are not going to be a part of the lectures. So in order to do that, you will have to learn them independently by yourselves. You have to read the textbook. So they are described in the textbook. So you just need to read a little bit further. But the problem here is that, you know, in order to understand this theory, this theory is based on theory that is taught in lectures, but it is taught only in the end of the semester. So if you want to do this advanced stuff, then you will have to somehow do self-study in advance. So that's why it is hard. All right. These things can be done just by a single person. So the presentation slides can be prepared by a single person, model fitting can be done by a single person, simulation can be done by a single person, and so on. But this has to be done together. So after the model has been finalized, fit into data, and you have a specific system of differential equations, then you need to do this analysis of critical points in their stability that you will be taught in the lectures explicitly. And again, this is important part of the material and everyone should know how to do it. So please make sure that everyone in the team understands this, because again, there will be the second presentation. I'll tell about it later, but someone has to write the report. What I have in mind is that you will write it first. It should be ready by week 13, but you will still be able to adjust it a little bit after the presentation. So based on the feedback from the tutor and the peers, I guess it is a good idea to give you a few more days to be able to adjust the report. So that's why, although it should be ready on week 13, but you actually submit it after week 13. So after the semester is ended, during the study week, I don't know, Monday, Tuesday, maybe on Wednesday, you'll have to submit it. So, and then there is presentation 2, which is on week 13. That includes this analysis of critical points in their stability, simulations, and advanced mathematics. Here again, someone has to prepare the slides, but since the stability analysis has to be done together, so the person who presents the stability analysis will be nominated by the tutor the day before the presentation. So this is to ensure that everyone knows how to do it. The rest of the presenters can be chosen by the team. So if only one, like the smartest student, does advanced mathematics, then that smartest person can present the advanced mathematics, and the rest may not even understand it. Alright, so that's basically the structure of the whole thing. So you do research, topic selection, modeling, and stability analysis together. But data collection, model fitting, simulation, advanced mathematics, and preparing the slides and the final report can be done by different persons. Right? So in other words, there are 4 kind of jobs to be done together, and 1, 2, 3, 4, 5, 6, 7 jobs that can be done individually. So I hope you see that there are both grounds for teamwork and individual work, and the project is very comprehensive. It cannot be done by a single person, so there is work for everyone, and I hope that you will work productively. Anyway, besides this, how do we ensure that everyone contributes to the project work, and at the same time that the assessment is fair, at least as fair as possible? So one thing that these things are kind of new, so I am introducing them. You didn't have them in Algorithms and Computing 3, but now we have them. So these are a result of my thoughts and of feedback that I got from you as in form of forum messages and some emails from Algorithms and Computing 3. So anyway, so one thing that you will have to do is to keep a research log. So every time team members are meeting, and even if just one person does an individual job, please write a record into the research log. So it is going to be a shared Google document. Everyone has access to it. So you just write who was present and what was done. So if, say, you just met for half an hour and discussed the topic, then you just write it like that. The following students were present. We met for half an hour, discussed the topic. So very, very simple, but at least in the end of the semester, there is the full log of all the activities that the tutor can look at and the other team members can look at. So then, sometime in the middle of the semester, every team will be assigned a leader, right? So one of the students is going to be nominated as the team leader. So of course, it is decided by the team themselves, but if they cannot decide, then the team leader is going to be nominated by the tutor. And the team leader is going to communicate to the tutor who is doing what, basically, right? So the team leader will tell you, will make sure that everyone is organized in the sense that everyone knows what to do. So the team leader will tell, okay, so you do data collection, you do simulation, you do advanced mathematics, and so on. Then, again, I will tell it, I already said it, but I'll repeat. So the presenters are going to be, at least some parts of the work must be done together. And presenters of those parts will be nominated by the tutor right before the presentation, just one day. That is to make sure that everyone understands these parts that are like the most basic and the most crucial for the work. Yeah, and finally, assessment by the tutor is done after peer assessment, right? So in the end of the semester, you do peer assessment, you provide feedback to each other, you provide grades to each other. After it is finalized, you get the grade from the tutor. So the reason is because if, say, to prevent you from penalizing teammates who did a poor job, because one person may be responsible for, say, writing the report or writing the computer program, so data collection. But everyone should have some idea of what it is about, and everyone should read it and look for mistakes. So that's why you shouldn't penalize each other for doing a poor job. If, say, that there is a lot of typo errors in the final report, that's not just the fault of the person who wrote the report, but it is everyone's fault because you didn't check. All right? So I hope it is clear. So again, that's the structure of the project work. Project is 40% of the entire course mark, and I hope you will enjoy it.